Ladies and gentlemen, welcome back to the Rakuten booth theatre at MWC Barcelona 2024. Next up, I'm very excited to introduce our next session, where we will hear about the partnership between Rakuten and zTouch to introduce the vision of OSS 2.0. It's my great pleasure to welcome our speakers for this session, Dr. Tommaso Melodia, Director of the Institute of the Wireless Internet of Things at Northeastern University, Anshul Bhatt, the Chief Product Officer of Rakuten Symphony's OSS Business Unit, and Medithe, the Chief Data and AI Officer for Rakuten Mobile. Without further ado, I'll hand over to our first speaker of the day. Please give him a round of applause, ladies and gents. Anshul Bhatt, the Chief Product Officer of Rakuten Symphony OSS.
Hello, everyone. Again, Anshul this side. Happy to be here. We are going to talk about our vision and plan for collaboration on the RIC, AI Powered RApps, XApps, and DApps with the collaboration that we are doing with Rakuten Mobile and Northeastern University. So without further ado, let me jump into some of the introductory aspects, and then I'll hand it over to Professor Tommaso and Madhu to take you further on the introduction on details on the collaboration. So what we are going to discuss here is how, with our OSS 2.0 vision, we want to move more towards the AI-powered way of network operations, especially with the aspects related to RIC and RApps to start with, in terms of how we can have more intent-driven, more AI-driven management and operations on Open RAN. And I'll talk briefly on our architecture for SMO and RIC, and then we'll describe you some of the use cases that we have implemented in Rakuten Mobile. And to take those use cases further with more apps on our RIC platform, we are collaborating with zTouch and Northeastern University to prove some of the use cases and some of the key results that we are expecting out of this collaboration. So here we go. So I think just a quick intro on what we mean when we say OSS 2.0. So from our history of last 5 years, since we started Rakuten Mobile, we wanted to be in the forefront in terms of, whatever priorities the industry was seeing or talking about, we were already implementing that, starting with the single source of truth, single pane OSS and automation framework. Then comes cloud and having the cloud native microservice-based, platform-based architecture. So we implemented it already in 2019 when the industry was talking about it. And then comes the automation journey, our whole Rakuten network, so that we could operate it, deploy it at a fraction of time and scale. We actually implemented automation all through the deployment and operations lifecycle management. And now, while everyone is talking about AI, we want to present you some of the use cases that are already implemented in Rakuten Mobile and how we want to take this further by collaborating with some of the next generation research work that is happening at various universities like Northeastern University, for example, and how can we embed and include that piece of work within our framework at Rakuten Mobile. So this is a very high-level architecture of our open framework, our SMO and RIC framework that we are leveraging to operate and manage the Open RAN networks, including at Japan, Germany, 1&1, and some other deployments across. And as you can see here, we do have a lot of components that actually help you realize the RIC platform and the RIC vision, starting with the SMO exposure functions, the FCAPs, the data management, the orchestration workflows, the AI/ML engine. And on top of it, in the red color that you see, is our RIC framework in terms of hosting RApps and XApps and some of the use cases to manage the ORAN networks efficiently. And the components in red are essentially the part of our non-real-time RIC framework. We do have the near RT and RIC components that we are also working on in Rakuten Mobile. And along with is the orchestrator framework that enables or helps this RIC platform to operate with, which is integrated with our Open RAN software and in a couple of other operator deployments with other Open RAN software versions as well. So without further ado, let me hand it over to Madhu, who can take you through the journey of some of these RApps that are live in Rakuten Mobile, and then how we are planning to further take them to the next level with the help of AI and intent-powered RIC apps with Northeastern University and zTouch. Thank you.
Thank you, Anshul. Good afternoon, everybody. So before we get into the basic theme of why we wanted to have RIC in Rakuten Mobile, I just wanted to take one step back. We noticed that it is necessity for us to have an automation from the day zero when trying to deploy our solution and getting into live in 2019 itself only. If you see broadly, in general traditional deployment perspective, we have automation as a different entity, SON as a different entity, and other frameworks, AI, ML as a different entity. They're working 3 different or 4 different portfolios independently. So, but when we wanted to execute these things in the network, and when they are executing these things in the network, like it's SON, or be it AML, or be it your automation framework, or maybe OSS automation framework, there is no coherence, there is no central database who is looking into that, who's actually looking at all the KPIs parameters, which actually tuning the network perspective, because someone will do its own mechanism based on its learning, and automation does its own learning based on its thresholds. So it's a statistical model. So we feel like we should have a something intelligent controller should have in our network. That is called RIC has come into picture. So we closely looking into this working group 2, working group 3 extensively, and of course we are the participants in the working group, these ORAN work groups, and we started developing this solution from 2021 onwards. So we have done our POCs, multiple POCs with ORAN HC software, and also we have collaborated with a couple of other vendors as well, but we felt whatever we have today, it has to come from the in-house perspective, because we have our entire automation suite, we have our AML running on our AI platform and data platforms, and then we have our own automation working in as an on-ops there. Anshul already mentioned as a part of our 2.0 or 1.2. So now, when we see from the application perspective, the main things which we are looking as like massive Memo optimization, when we go into the 5G kind of deployment, or when we go into the 4G kind of deployment, we see multiple interference is happening as the number of subscribers are going in the particular group of cells or particular cluster. So those we are trying to handle as a part of our own intelligent controller. And also we see that SON is a part of RIC solution. So they are all working together. When any particular parameter is getting changed, one of the key things what we see is the conflict mitigation. There's something which I have explained yesterday. So which actually looking over all these things. So whatever we're trying to execute in the real time, we know what is executing it. We know what parameters are going to impact. We know what and all the cells are going to impact. That's what RIC is actually enabling us. So rather than working in a distributed way, the centralized component RIC actually enable all the applications in a single set. So some of the applications, what we see is SSV beam optimization, and as well as traffic steering applications based on the ORAN standards. And one of the key applications which we have deployed today on the RIC platform is energy savings, which we already explained in yesterday's session, where we are actually able to get on close to 20 to 25% today, both as an XApp and RAPs. We have 2 different segments over there, depends upon the use case to use case. So that's already been deployed in our solution. So we are achieving around close to 15 to 20% in XApps, and as well as 20 to 25% as an RAP based on the use case to use case. Yep. Yeah, from here onwards, I would like to hand over to Thompson. Please have.
Yeah,
thank you.
Thank you, folks. Thanks for the introduction. It's a pleasure to be here. Tommaso Melodia. I'm a professor at Northeastern University and a co-founder of zTouch that is going to be partnering with Rakuten and Rakuten Mobile and Rakuten Symphony. We're very excited with this partnership. We've been working for a number of years to lay the foundations and to develop practical solutions that leverage AI to generate the next generation of open, programmable, and virtualized wireless systems. zTouch is the result of this work that has been going on for a number of years with funding primarily from the U.S. federal government, directed at creating the next generation of AI-powered radio access networks. Okay, so what is the vision for zTouch? zTouch is looking at creating intent-based networks where you can define at a high level an intent. Down the line, this is going to be done with large language models. As of today, it's done with machine understandable languages. I want to configure a network to minimize the latency and reduce the energy consumption, or I want to create some specific use cases that support slicing in a certain part of the network. zTouch has two main components: the zTouch operating system and the zTouch SDK. The SDK enables us to define at a high level the intent. The operating system takes the intent defined by the network operator at a high level and converts it into a set of machine learning models that are selected from a catalog of pre-trained models, or they can be trained on the fly based on information on data that has been collected in a data lake. And then it automatically deploys the AI models that are necessary to obtain the intent that has been defined by the operator in the network in a matter of seconds, and it deploys it in the form of XApps and RApps. XApps and RApps, we talked about it earlier. RApps are applications that have the closed loops functionalities with time scales in the order of seconds to minutes. XApps are closed loop control applications that have latencies in the order of tens of milliseconds up to 1 second. We have also introduced at zTouch the notion of DApps. This is something that is going to be also hopefully tested within our collaboration with Rakuten. DApps are applications that require closed loop, that require authentic real time, right, below tens of milliseconds, and are expected to be executed directly on the DU or the CU components of the disaggregated open radio access network. So XApps on the near real-time RIC, RApps on the non-real-time RIC, and DApps directly executed on the radio access network. The general idea is zero-touch selection, deployment, and monitoring of these applications. And this is a technology that exists today, it's working, and will be tested in our collaboration with Rakuten. An example of some of the XApps that have been developed, run slicing XApp that uses the E2 service model with cell configuration and control. So the general idea is you have XApps that read the KPMs and define slicing policies to prioritize traffic, where you can provide services for slices that are ultra reliable, low latency, or enhanced mobile broadband. And the slicing policy interacts directly with the scheduler on the radio access network to provide the scheduling functionalities that will enforce the slicing policy. Another example, this will be executed as an RApp, is automated cell configuration. Configuring cells in the same area, assigning spectrum from a pool of channels that are available, power, numerology, and frame structure, and also enabling neutral host. There is technology developed by zTouch that enables supporting multiple mobile virtual network operators on the same neutral host, and automatically configures the network, including the frequencies, as well as the resource blocks to be assigned to different entities based on this. This is an example of XApp. So this was supposed to be an animation, but I'll describe what was going to happen. This shows the orchestrator from XApp for XApps, and specifically there is a high level intent selection dashboard where the operator can define specifically what he wants to achieve. For example, creating a certain set of slices, each individual slice supporting traffic with different characteristics. It can be enhanced mobile broadband, ultra reliable, low latency, machine type communication, or other more custom ad hoc slices. You select the intent from this high level dashboard, and the system automatically deploys the right XApps on the near real-time RIC to provide enforcement of the policies that have been defined by at a high level. And this operates in an automation environment. Today, it operates in a Red Hat OpenShift environment. that manages all the life cycle of the containers that implement the intent generation as well as the RApps and XApps, and this will be integrated in the Rakuten environment. This is another example. This is a demo that is done with a live dashboard. If anybody's interested, I'll be glad to show the demo later offline. But you have the ability with a dashboard to enforce to define different policies for slicing, following the 3GPP model for slicing, and that is automatically deployed on a radio access network. This is working live with an ORAN multi-vendor fully virtualized radio access network that is in our testing facility. So it's fully integrated with RAN. It's not something that runs exclusively on cloud. And this is a different example that shows the ability to automatically allocate resource blocks and schedulers to different slices with enhanced mobile broadband, machine type communication, ultra reliable low latency slice. What we have here is zTouch deploys XApps that have been trained based on data to automatically control the number of resource blocks and what specific resource blocks to assign to each slice to enforce the policies that have been defined at a high level in the form of intents. And it also assigned the scheduler, the best scheduler to be able to enforce the policies that have been defined. This is, I believe, certainly one of the first demonstrations of automatic optimization of radio access network slicing based on deep reinforcement learning, artificial intelligence models. This demonstration has been done based on data that has been collected with the world's largest simulator of wireless systems called Colosseum. It's basically a data center that is in our Burlington, Massachusetts facilities. It contains 25 racks of equipment, high-performance computers, CPUs, GPUs, and it's connected to 256 software-defined radios that can emulate in real time the behavior of the radios, including collocated G-Node Bs and mobile UEs. And then we run virtualized radio access networks on top of this compute and software-defined radio infrastructure. And the different software-defined radios are also interconnected through a fabric of FPGAs that can emulate in real time the 256 times 256 channels that compose the radio access network. So we can create a fully virtualized environment in which we can model real scenarios. It can represent an indoor space, a portion of a city, deploy in this virtual environment, let's call it a digital twin, deploy the G-Node Bs and the mobile UEs, create mobility scenarios, collect the data, use the data to train our XApps, and then make them part of the automation framework that zTouch provides. So, summarize, we're excited with this partnership, the opportunity to work with real data, with a real radio access network, and we think that this partnership will lead us pretty far. Thank you.